Hello everyone, welcome to today's video session on resistance welding. Resistance welding is a process of joining metals by applying pressure and passing electric current through the metal which is to be joined. The process is extremely cost effective. There are different forms of resistance welding like spot welding, seam welding, projection welding and butt welding. These welding types differ primarily by the shape of weld electrodes that are used to apply pressure and conduct the current. The electrodes typically manufactured from copper-based alloys due to superior conductive properties and are cooled by water flowing through the cavities inside the electrode. Resistance welding machines are designed and built for a wide range of automotive, aerospace and industrial applications. Resistance welding is a welding process in which the workpieces are joined by the heat generated due to the resistance offered by the workpieces to the flow of electric current through them. A certain amount of pressure is applied to the workpieces to complete the weld. The basic principle of resistance welding is that when electric current flows through the material, it offers resistance to the flow of current, resulting in heating the material. The heat generated is used to make the weld between the workpieces. The resistance welding is based on this above principle. The heat generated in the material is given by Joule's law, H proportional to I square RT, where H is the heat generated in the material, I is the flow of current through the material, R is the electric resistance of the material, and T is the time for which the electric current flows through the material. The basic requirement for resistance welding is very high current and application of pressure. Few of the resistance welding process are spot welding, seam welding, butt welding and projection welding. Let us now discuss each process in detail. Spot welding is a resistance welding process in which the two overlapping workpieces held under the pressure are joined together at one spot. Hence, the name spot welding has been more popular. The basic equipment required for spot welding is the water-cooled copper electrodes, the workpieces, step-down transformer which converts high voltage low current into low voltage high current, and a mechanism to apply external pressure. Spot welding process has basically 4 stages. In the first stage, the workpieces are held between two electrodes which are connected to step-down transformer, which in turn is connected to a power supply. When the current is switched on, the high current flows into the workpieces through electrodes. Due to the resistance offered by the workpieces, there will be a localized heating at the contact area of the workpieces. Later, the current is switched off and a pressure is applied so that the workpieces will join together at the contact area. Once the pressure is released and the workpieces are allowed to cool, we will be able to obtain spot welding. Let us visualize and see much detail about spot welding process. Let us understand the spot welding process in much detail. Before the process, the two workpieces to be joined must be cleaned to remove dirt, grease and other oxides. The workpieces are then overlapped and placed firmly between two water-cooled copper alloy electrodes. These electrodes are connected to a step-down transformer, which is in turn connected to an AC power supply. When the electric current is switched on, the current passes through the electrodes to the workpiece. Heat is generated in the air gap at the point of contact at the two workpieces. This area is called as weld nugget or spot weld. The heat at this contact point is maximum with the temperature varying from 800 to 900 degrees Celsius, and as a result it melts the workpiece locally at the contact point to form a spot weld. After the power is switched off, an external pressure is applied to the workpiece through the electrode by means of a piston cylinder arrangement. The pressure is released and the workpiece is allowed to cool for some time to form a strong weld. Let us discuss various advantages, disadvantages and applications of spot welding process. In this process, there will be only localized melting of workpiece. No other portion in the workpiece will be melted. The process has got very high production rates and the process can be easily automated. There is no requirement for a filler metal or flux in this process. Let us now discuss few disadvantages of this process. The initial investment is very high and also the strength of the weld is less compared to other welding process. This process is mainly used in case of welding handles of cooking utensils and very much popular in welding of automobiles. Seam welding is a resistance welding process in which the overlapping workpieces held under the pressure are joined together by a series of spot welds made progressively along the joint, utilizing the heat generated by the electrical resistance of the workpieces. Seam welding is similar to spot welding process, but instead of pointed electrodes, mechanically driven wheel-shaped electrodes are used to produce a continuous weld. Let us understand in detail the process of seam welding. Let us consider two metal sheets and try to join them. For this, we overlap one sheet over the other and place them between two wheels which are made up of copper alloys. These wheels are connected to the secondary circuit of a step-down transformer. Now let us attach a load to the shaft of the upper wheel and we apply pressure. Now let us mechanically rotate the wheels in opposite direction and connect the step-down transformer to a AC power supply. The transformer drops down the AC supply voltage, due to which a high current is received at the copper alloy wheels. Since we know that the resistance between the metal sheets is high, large amount of heat is produced when high current flows through it. Due to this heat, we see that semi-molten joint is formed between the surfaces of the plate. The joints are made stronger by the pressing force. Since we are rotating the wheels in opposite directions, the metal sheets move linearly and continuous weld is formed between them. This method of joining two or more metal sheets by forming a seam between them is called as seam welding process. Let us now discuss advantages, disadvantages and applications of seam welding process. The process can be automated similar to spot welding process, and this process has high production rates. In this process also, there is no necessity of using filler metal or flux. Unlike spot welding process, this process produces continuous welds. Let us now discuss few disadvantages of this process. Initial cost to set up this process is very high. Also, it is very much difficult to weld metals having thickness more than 3 mm. Let us now discuss few applications of seam welding process. Seam welding process is often found in welding of fuel tanks as well as steel cans. The next type of resistance welding is flash butt welding, or it is also called as resistance butt welding or upset welding. This welding is an example of resistance welding process in which the two parts to be joined are heated to elevated temperatures and they are forged by applying the desired pressure at that particular temperature. This process consists of workpieces mounted on a clamp where one of the clamp is movable and another clamp is stationary. Additional mechanism is required to apply force on the workpieces. Let us now study resistance butt welding process in detail. Let us consider two rods having same cross-sectional area. Now let us try to join these rods. For this, we mount the rods on carbon clamps such that one of the clamp is fixed while the other one is free to move. Now we clamp the rods between the two clamps tightly by closing in the movable clamp. Now let us connect the carbon clamps to AC power supply. When the current flows through the rods, due to high contact resistance, a large amount of heat is produced. Since the melting point of the carbon is very high, we see that the clamps do not melt. But the rods at the contact area will melt. Now we apply an additional mechanical force on the rods by moving the movable clamp close to the immovable clamp. After some time, we disconnect the AC power supply. We see that the molten metal cools and the rods get joined by a strong weld. This process of welding is known as resistance butt welding. Let us now discuss the advantages, disadvantages and applications of resistance butt welding process. Similar to other process, even this process can be easily automated and has got very high production rates. This process produces a defect-free joint. The main disadvantage of this process is that the parts with similar cross sections can be joined. Also, the workpiece requires extensive joint preparation during the process. The common application areas of this process are welding, shopping trolleys as well as wire baskets. Projection welding is a resistance welding process where the design or shape of the part is used to make discrete individual contact points through which the current is concentrated during the welding process. Projection welding is actually the modification of spot welding process. To understand the concept of projection welding, let us consider two pieces, say a flat metal sheet and a nut, and try to join them together. We see that the nut has some projections on its surface. Now let us place the nut on the metal sheet such that only the projections are in contact with the sheet. Then we place the workpieces between two electrodes. which are connected to a step-down transformer, which in turn is connected to AC power supply. Now let us move the electrodes towards each other so that the workpiece are tightly gripped between them. Now we switch on the power supply. We see that current flows through the nut and the sheet through the projections. Since the contact resistance at the projections is very high, we see that a large amount of heat is produced at the projections, due to which the projections will melt. Now let us tighten the grip around the workpiece by applying some force on both the electrodes. We see that the molten projections get squeezed between the workpiece and solidify among multiple spots. The number of weld spots formed is equal to number of projections. This process of joining two workpieces by forming weld spots in the place of projections is known as projection welding. Let us discuss the advantages of projection welding process. This process produces uniform welds and it is suitable for thick sections, and the process is economical. One of the major disadvantages of this process is it cannot be used for thin sections, and all the projections must be of same height to obtain the proper weld. The common application of this process can be found in door hinges. Thank you for watching this video. We'll be meeting in the next video session with some other welding process. Till then, bye my dear friends. Have a nice day.